Okay, so guys, this line diagram that you see in front of you is the most important section in the freshwater generator manual. If you understand this line diagram properly, you understand how the freshwater generator is working and what all parameters you have to check when you see the working of freshwater generator, what all things are important to be noted. So let us see this line diagram. Okay.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Basically, through this line diagram, I will try to explain how the freshwater generator is working also. Okay, so as we already know, this is a vacuum distillation type plant where you are reducing the pressure in this cell and thus reducing the boiling point of the seawater, because as per the Gay-Lussac's law, pressure is directly proportional to temperature. Pressure is directly proportional to temperature. So if pressure reduces, your boiling point reduces, temperature reduces for the boiling. Okay, so that is why in this evaporator section, at less temperature also you have got boiling, seawater boiling. Okay, but how does this happen? Let us talk about that. So our line starts from here, from the sea chest. Okay, so in some of the vessels you will find that there is separate sea chest for the ejector pump also, and other sections you will be finding it connected with the low sea chest. Generally you will always be finding the ejector pump suction from the low sea chest. Why so? Because the vessel might be loaded and might be in draft conditions, but in the low sea chest section you will always have the draft will always have the seawater present over there. In the high sea chest, maybe it will rise above the water because of the draft condition. So generally at the lowest section of the vessel, it will have a connection from the sea chest. Okay, because separately, why? Because sometimes in low sea chest you might change over to high sea chest also, so you will close the valve. So always it will have a separate chest. Okay, ejector pump will have a separate chest connected to the low sea chest section. Okay, so that even if you are using the high sea chest, your ejector pump is continuously taking suction. Okay, or from the seawater line also sometimes it is connected to. So from the sea chest, basically seawater comes, it has passed into the strainer filter generally that you have in every pump suction. So that is thing. Then you have two reducers over here, you can see B1 and B2. If you go to the diagram over here, it is not mentioned, but these reducers are to increase the pressure, okay, in the ejector pump. So ejector pump should have enough pressure around 4 to 4.5 bar pressure in the, so you have a reducer, so due to which your as this reducer is there, you will have increased velocity over here, and due to which the flow will be also important. So in ejector pump, it is not just the pressure, it is also the flow which is important. To make it should have an effective flow of water towards the freshwater generator. Okay, why is flow important? Because the amount of water required for condensation in the condenser is the factor which decides how much cooling will be given. So from the ejector pump, your water goes into, seawater goes into the condenser plates. Okay, there will be two chambers. One by one the two plates will be joining each other. So one chamber will be having seawater. Okay, this seawater, cold seawater coming from, I mean the seawater coming from the ejector pump, and then one chamber will have the evaporated steam coming in, which is being, so you will have, if I change the color over here, one section you will have steam, one section you will have water, seawater. Okay, so this seawater gets inside, cools the steam and goes out from here. Okay, now important thing, the seawater inlet side has got a temperature indicator over here, temperature gauge. Okay, so one temperature indicator here, one temperature indicator is in the outlet, condenser outlet. The purpose of these two temperature indicators, and it's very important to note the difference in this temperature. How will you come to know? So say the seawater temperature over here, which is entering, the seawater entering is 30 degrees centigrade. Okay, suppose 30 degrees centigrade seawater is going into the condenser, and the condenser seawater outlet temperature is 40 degrees centigrade. Okay, it is okay. Say if it is 38 degrees centigrade, so only there is an 8 degrees centigrade increase in the temperature of the seawater when it has gone through the condenser and come out, only 8 degrees. So as per the manual, we will see it will come in the manual only. If the temperature difference between the inlet and outlet is less than 10 degrees centigrade, that means if the temperature difference is less than 10 degrees centigrade, that means your condenser plates are dirty. Okay, there is mud, dirt, debris settled in the condenser plates. Why important? Why? So if there is proper heat exchange, there will be a definite drop of more than 10 degrees centigrade in the temperature. It has to it has to increase, I mean, because it will cool the steam and it will get heated up in turn. So there will be an increase in temperature more than 10 degrees centigrade. Okay, so this if it is inlet side is having 30, it has to be more than 40 in the outlet side. Okay, so this is the seawater funda. So you have always check the inlet side seawater temperature and outlet side seawater temperature. Okay, now you have different components installed on the body over here. The one is a safety valve. So what is the purpose of safety valve over here? The purpose of safety valve is basically say by mistake if some of the valve is left closed in this section, say you forget to close the overboard valve, seawater is going in, coming from here and getting pressurized, the pipeline is getting pressurized, the plates are getting pressurized, plates have started leaking and then seawater has accumulated, or say your eductor is not functioning properly, brine is filling up, it's a vessel is an UMS, nobody is seeing, the alarm is not coming, and the cell completely gets filled up. So in that case, due to over pressurization, the cell does not burst out. You have got a safety valve over here to release the excessive pressure in the cell, because this is a closed chamber cell. You will always have a additional safety given in terms of a safety valve to release the excess pressure. Okay, otherwise it is always in vacuum, but say in case of an emergency, sometimes if there is something filled up, fresh water, seawater filled up, and it is not escaping out from somewhere, the safety valve will generally lift. Okay. Then you have the air vent. The air vent or the vacuum breaker as we call it is also a very important component over here. Okay. So in case when you have vacuum say 90%, even when the freshwater generator is running, the vacuum breaker should be closed, and when you stop the freshwater generator you have to open the vacuum breaker so that, or the vent, so that the air which is trapped inside, I mean it comes at the atmospheric pressure. The same, the chamber should come at atmospheric pressure. What consequence will happen, you think now, we will discuss later on. What consequence can happen if you leave the vent valve closed, we don't open it if it is the freshwater generator stopping. Then you have got a temperature indicator. This is for the shell temperature. Okay. This is for the shell temperature to check the temperature of the complete unit over here. The steam that is coming in and condensing near the condenser, what is the temperature generally fitted at the top of the shell. So shell temperature and vacuum have direct correlation. Okay. If your shell temperature if your vacuum drops, your shell temperature will increase. Okay, we will come to all these equations. Okay, then you have a pressure indicator also. What is the pressure of the shell pressure? You can see over here P1E1 is a vacuum gauge. Sorry, vacuum gauge. This is a vacuum gauge, and there is a this is the vacuum gauge. So here is where you will see the vacuum present in the freshwater generator. Okay, whatever vacuum you have in the freshwater generator, you will see over in this section. Now we come to this section. So the seawater is coming out from this section. Here you have a pressure indicator. Why is this pressure indicator important? This pressure indicator will show you how much is the pressure over here which is going into the eductor. Okay, so it should not be less than 3 bar. The pressure drop should also not be more than 1.5 bar inside the condenser. So it should be minimum 3 bar pressure which is going into the eductor. Okay, so that is the eductor line, and from the eductor line it is going overboard. What is happening here in the eductor? So as we know from the continuity equation, A1 V1 is equals to A2 V2. Area into velocity is equals to, in this section, if area is over here, so when you increase the area, what happens? Your velocity reduces, and when you reduce the area, your velocity increases. So basically here you will have a nozzle fitted. So due to this, the nozzle is basically reducing the area. When you reduce the area, your velocity increases. When velocity increases, so V2 will always be higher. So when you have higher velocity V2, what happens? Your kinetic energy we write with velocity half m into V2 square, velocity square. So kinetic energy increases. If kinetic energy increases, what happens is there is a drop in pressure energy. Because of conservation of energy, kinetic energy plus potential energy is constant. Conservation of energy, right? So if kinetic energy increases, the potential energy or the pressure energy has to drop. So in the section, just in the nozzle section, you will have a negative pressure over here. Because of the negative pressure, vacuum will be generated. Okay, pressure will drop, so there will be a jet of water flowing. Due to the increase in velocity, this jet of water will reduce the pressure and it will create a sucking effect. When you suck something, what you do, you create negative pressure by pulling up the air so fast from a straw. We create a negative pressure. So similarly, in this case, negative pressure is created in this line, and it draws the brine from the evaporator bottom, okay, due to the negative pressure. And also one important line is here. This is the line called the air ejection line. Okay, and from this air ejection line it is drawn inside the ejector. So this is a non-return valve, and through this non-return valve air will come inside the ejector, due to which your condenser will always be in vacuum. And that is the most important concept. If you have steam coming on the top of the condenser, it has to be driven by something which is taking the steam inside the condenser, and then this air ejector is playing that important role of creating vacuum inside this condenser plates. So thereby this steam is going inside the condenser plates due to the air ejector. Okay, air ejection. So through this non-return valve has got a small ball of green or yellow whitish color, and it should always be driven towards the ejector side, towards the end side. Okay, towards the ejector side, not towards the condenser side, because it will always be drawing air on this side. So pressure, negative pressure will be on this side, so it will always go towards the ejector. So in this video we will be discussing until this much. In the next one we will discuss the rest of the line diagram. Okay, thank you guys.